Right, okay then, we will make a start then. Now, just to recap what we did in yesterday's lesson and also what we've done in geometric series before. If we want to find any term in a geometric sequence, we use this following formula here to find any term in the sequence. And if we want to find the sum of the first n terms in the series, we can use either one of these two formulae here. Okay, for this one you do get given in the formula book. But as we saw yesterday, we do need to still know how to prove these formulae. Now, what we're going to focus on today is a divergent and convergent geometric series. And we're also going to then look at, if it's convergent, how we can find what we call the sum to infinity. Now, a divergent series is where the terms get larger and larger and larger. So, for example, if you have a sequence that goes 2, 4, 8, 16, 32, etc., that's a divergent series. Okay, it's never going to a specific number. So basically, if it's divergent, as n tends to infinity, so as n gets to a really, really, really large number, the sum of the series also tends to a large number, as you can imagine. Okay, if the terms are getting larger and larger, then obviously the sum is going to be getting larger and larger. A series is convergent if the successive terms get smaller and smaller to approach a limit. What this means is, as n gets really big, the sum of the values gets closer and closer to a finite value, which we call the sum to infinity. What this means is, as n gets really large, r to the power of n, so your n plus 1 term essentially, will be 0. So therefore, if we take our series that we looked at yesterday, so we take this formula here that I'm just going to highlight in yellow. So this is the sum formula that we looked at yesterday. And if n is a really large number, then what happens is this will just end up being a over 1 minus r, because as r to the power of n, sorry, as n gets really large, r to the power of n just simply becomes 0. So imagine if r is, let's say, a half. Well, a half to the power of a really large number is just going to be 0. So what happens is in that bracket, you just end up with 1 minus 0. So then you just end up with a over 1 minus r. But that's only if this value of r is between 1 and minus 1. So it's only only convergent when r is between minus 1 and 1. What this r in the lines mean, you may have met this before when we did binomial expansion, is this means it's the modulus of r. Okay, so whatever value r is, we always take the positive version of it. So basically what this means is, if r is between minus 1 and 1, the series will converge. If it's greater than 1, or if it's less than minus 1, then the series will diverge. Now, I've tried to avoid talking about current situations in the world as of late, but I feel like this is actually really quite relevant to what is happening in the world right now. You may have heard something called the R number in the news. Okay, what this is, it's about the rate of infection, and you might have heard they keep saying on the news that they want to get R below 1. And really, this is just all geometric sequences here, okay, or geometric series. The whole idea of R is it's the rate of infection. Now, if R, let's say, is 2, what that means is if one person is infected, then they will pass it on to 2 people, and those 2 people will then pass it on to 4 people, and so on. So you sequence, so let's just choose a different number now. Let's say we start with 1,000 people. If R is 2, we go 1,000, 2,000, 4,000, 8,000. And then you see that exponential growth. So that's an example of a divergent series. But now let's say R is less than 1. So you've got R is, let's say, a half. Well, that 1,000 then becomes 500, which then becomes 250. And then we're seeing that exponential decay. And that's what we want, obviously. Okay, we want that number to go down. It will then converge to a particular number at the end, and that would be the number of people that were affected altogether once you add all those terms together. So just wanted to mention that just because I think it's actually quite a relevant example. So the key things here that you need to know is a geometric series is convergent if and only if the modulus of r is less than 1. Basically, if r is between -1 and 1, because then your series will just end up going to your m. As n goes to infinity, your terms will just go to 0, and then you'll be able to add all those numbers up to get to converge to a particular limit. And then we need to also know the sum to infinity to find out what the sum of that sequence is, of that series is, and we just use this formula a over 1 minus r. So let's do an example to see how this works. A geometric progression has first term 12 and second term 8. Find the sum of the first 8 terms and the sum to infinity. So we have geometric progression. We know our first term, our a, is 12. And we know that r is just the second term divided by the first one. R is just 2/3. And this is just what we were doing yesterday, finding the sum, the first part of this anyway, is find the sum of the first 8 terms. So I want to find S8. And to do this, I just use the formula that we introduced yesterday. So just be careful as you put this all in on your calculator that you don't make any mistakes with BIDMAS, any mistakes with your negatives. And if you want it exact, it's 25,220 over 729. If you want it as a decimal, it's 34.60. Normally we do like our exact numbers, but that's actually quite hard to comprehend that fraction. And I want to show you the difference between the sum to of the first 8 terms and the sum to infinity as well. So that's why I want to put it as an actual number, as a decimal there. And then we find the sum to infinity. So we just simply use our new formula, a minus 1 over r. Basically, it's just that same formula that we just used for S8, except for in that bracket, it's just going to go to 1. So a is 12, our first term, and then we do 1 minus the common ratio of 2/3, and this just gives us 36. So you can see that the first 8 terms come to make 34.68. You can see that each term is getting smaller and smaller. Okay, the first term's 12, and the next term's 8, and then the next term will be 16 over 3, and so on. So the terms are getting smaller and smaller and smaller. So each time you're adding on a smaller and smaller number to the point where essentially you're just adding on 0, because it's just going to tend towards 0. It never actually be exactly 0, but it will essentially be 0. So then as you keep on adding these terms, eventually it will just converge to the number 36 as n tends to infinity. So you have infinite terms in this sequence, it will just end up converging to 36. And remember, it converges because r is between -1 and +1. Okay, r's 2/3, so it's a converging series. If there's any questions, please let me know in the chat below. If not, we will move on to example 11, where we have the 4th term of a geometric series is 1.08 and the 7th term is 0.23328. Firstly, we're going to show that this series is convergent. Now, if I want to show that it's convergent, I need to find the common ratio first. So to do this, I'm going to write down the information I know. So firstly, AR cubed equals 1.08. This is because the 4th term is 1.08. So I know I need to use the formula a times r to the power of n minus 1 equals that 4th term, where n is just going to be 4. So remember, that 3 just comes from 4 minus 1. The 7th term is 0.23328. So I'll also write that down. And now I have equations 1 and 2. So just the first question for the chat is, how do we end up finding what R is from here? What do I need to do to solve this? So I just want to find what R is to check if it is convergent or not. Yep, so that'll be saying 2 divided by 1. Yeah, so equation 2 divided by 1. So we just do equation 2 divided by 1. And what happens is the a's will cancel. And r to the power of 6 divided by r to the power of 3 just gives me r to the power of 3. And when I put these decimals in my calculator, I get 27 over 125. So then I can just cube root both numbers. And this is actually quite a nice number because cube root of 27 is just 3. The cube root of 125 is just 5. So I just get that r equals 3/5. So why is this series convergent? So question for you now, why is this series convergent? Yeah, r is less than 1. Just when we say, I know it's, imagine you can't really put it in on the chat there. Just remember it's that r is the modulus of r is less than 1. Okay, for example, if you have r as -2, it's still a divergent series because if you're multiplying by -2 each time, it's not going to go to 0. But obviously, I know that it's difficult to put that in on the chat there. So r is between -1 and 1, or the modulus of r is less than 1. So r is 3/5, so we know it's convergent. As the modulus of r is less than 1. So part B, we need to find the sum to infinity. Now we know that r is 3/5, but also what we need to know is our first term a. To do that, we can just simply sub r equals 3/5 into equation 1, and we just get that a is 5. So now we have our first term, we have our common ratio. So we just do a divided by 1 minus r. And we get 25 over 2, or 12.5 when we do so. So as you keep adding these terms, they're just going to end up converging to that 12.5. Just make that nice and clear, just in case. Unless any questions, we'll move on to example 12. And then we've got a couple of past paper questions to have a look at. So our next example, for a geometric series with first term a and common ratio are the sum of the first 4 terms is 15 and the sum to infinity is 16. Part A wants us to find the possible values of r. What I'm going to do is I'm going to write down any formulae that I can extract from that question. Okay, so what you should always be trying to do in a lot of exam questions is try and write down any formulae that you can from the information you're given. Now, the first thing I want to look at is the sum of the first 4 terms is 15. So for this, I just need to use the formula that for the sum of any terms in the series. So in this case, I'm just using the fact that the sum of the first 4 terms, so S4, is 15. A, I don't know yet. N is going to be 4 here. And yet again, R, I don't know. So from that first piece of information I've highlighted in blue, that is what I can write down as a formula for. And then we're going to write down the sum to infinity is 16. So as best as you can in the chat, can you write me down the formula for this piece of information? The sum to infinity is 16. So how can we write a formula expressing that information? Okay, excellent. I can see some fantastic responses here that we're going to write it down as. That's really brilliant to see from everyone. Normally try and read out the names, but there's so many of you that got this, so that's good to see. So the sum to infinity is 16, and then we just write a over 1 minus r. Now, the next bit, and really the good thing about that is really kind of means we haven't got to do as much reading now. All we need to do is find the possible values of r, okay? So we don't really need to read too much into the question anymore. We've got all our equations down there. Now it's just time to solve. Now, what I want to do is combine these two equations somehow. There's all sorts of rearranging you can do, but what I would notice here is that I can see an a over 1 minus r here, and I can see an a over 1 minus r here. Now I know that a over 1 minus r just equals 16. So what I can do is simply just replace a over 1 minus r. Wherever I see that, I can just now replace it with a 16, because I know the value of a over 1 minus r is just going to be 16. From here, I can now just start to solve this equation. So firstly, I'm going to divide both sides by 16. Remember what your goal is here, is to try and find r. So what I want to do is try and isolate r on its own. So then I'm going to take away, well, I'm going to add r to the power of 4 to both sides, and then take away 15 over 16 from both sides, and I get 1 over 16. So what value of r am I going to get then here? So anyone tell me my what answer I'm going to get here for part A? So a lot of you saying a half. I feel like it's been too long since we've been out of the classroom. We're just saying a half. There we go. They're coming through now. Plus, thank you for the capitals, Harry. Plus or minus. Okay, those of you that normally have me as a teacher, you know that I like to kind of usually pause at this point for people to tell me plus or minus, because we've got a fourth root here, so we can have positive and negative solution. Another giveaway is that we're looking at values of r, the key letter there being that s, meaning we've got more than one to find. So we could have positive half, and we could also have negative a half as well. Okay, those are two possible solutions to this. So plus and minus a half there. And then part B, given that all the terms in the series are positive. Okay, so I know I made that big deal about it's positive or negative for that part. Turns out they are all positive, but still, it was important for part A. Given that all terms of the series are positive, find the value of A. So all we now need to do is just use r equals a half, and we just plug that into the second equation there. So 16 equals a over 1 minus a half. With a little bit of rearranging, we can just simply get that a is just going to be 8. That's your final answer there. Let us know if you've got any questions in the chat. We'll go on to these past paper questions, and then it will be over to you to have a go at some past paper questions yourself. Now, our first question, and quite similar to the last one, we're going to write down two pieces of information. So in a geometric progression, second term is -4, and the sum to infinity is 9, and we're asked to find r. So similar to the last question, I've got two pieces of information here, so I can form two equations from this. The first piece of information I'm told is that the second term is -4. That means that AR is just going to equal -4. Okay, that's just using the fact that AR to the power of n-1 finds you any term in the sequence. And then you're told that the sum to infinity is 9. So what this means is that a over 1 minus r equals 9. Now, what we will want to do is solve these simultaneously. There will be a couple of different ways that you could do this. What I would recommend here is just rearrange this second equation to make A the subject, and then you can simply substitute A into your equation. You could also rearrange the first equation for A and sub that in. You could rearrange the first equation for R and sub that in. That might be a little bit trickier because you end up with a fraction on your denominator. But whichever way you do it, you need to kind of solve these simultaneously. So just do this by substitution. So all I'm going to do now is replace A in the first equation with 9 minus 1. 9 times 1 minus R. And I also then need to times that by an R to give me minus 4. So all I'm doing is just replacing the A with that 9 times 1 minus R. So when I expand this bracket out, so I've got 9R times the 1 for 9R, and 9R times the minus R for 9 minus R squared. This becomes a quadratic. And we could reach for the calculator, but that would be spoiling the fun of factorizing this. So we are just going to factorize this and get 3R plus 1 times 3R minus 4. And we just get two solutions, R equals minus a third and R equals 4/3. So we're asked to find R here. Are both of these solutions here? Or have I only got one solution? Or have I got two solutions? Have I got no solutions? Okay, just put your thoughts in the chat below. Okay, James, you're saying it has to be minus a third. Why does it have to be minus a third? So Abby's saying, yeah, the 4/3 is bigger than 1. So why? Yeah, so yeah, so you're right to say there, James. It has a sum to infinity, so the modulus of R has to be less than 1. Okay. So since we're told the sum to infinity exists, we know that modulus of R has to be less than 1. So we only take the minus a third as a solution. We disregard this 4/3. Okay. By the way, I put a cross there. In your exam, I wouldn't recommend that you just cross through it. I'd recommend showing both your answers and then stating that the only solution is R equals minus a third, like I've done there. So just make it clear that you have worked out both solutions, but you are telling the examiner that actually you know that you're only taking that minus a third. Last question then. Just double check the chat. Anything else? Nope. So last question then for today. The first three terms of a sequence are 2x, x plus 4, and 2x minus 7, respectively. The first question asks us that given the sequence is arithmetic, find the value of x. So if it's arithmetic, we know that there is a common difference. So we know that what we have to add to go from 2x to x plus 4 has to be the same as what we have to add to go from x plus 4 to 2x plus 7. So basically what we're saying here is that u2 minus u1 equals u3 minus u2. Okay, the second term, take away the first term, has to be the same as the third term, take away the second term, because it's a common difference. And here we're talking about arithmetic series, so it's a common difference. Now we do x plus 4, take away 2x to begin with, and we know that has to be equal to 2x minus 7, take away the second term, which is x plus 4. This bracket is really important because if you just put minus x plus 4, you're going to be adding the 4 rather than taking the 4 on that right hand side. So really important that you put in the bracket, you've got to take the whole of that away from the 2x minus 7. With a little bit of rearranging, we'll end up with 4 minus, well, firstly just simplifying both sides, we get 4 minus x, and we get x minus 11. Add x to both sides and add 11 to both sides, and we'll end up with 2x equals 15. So x just equals 15 over 2. Okay, and so I'm just going to make that a little bit smaller, so give me room for the next part. Again, let me know if there's any questions. Now, part B says, given instead that the sequence is geometric, find the sum to infinity when x equals 8. So when x equals 8, our first term is going to be 16. And our value of r is just simply going to be 12 divided by 16. So we get 3 over 4. Okay, all I've done there is just if I sub in x into the sequence, the first term is 16. The next term, x plus 4, well, that's just going to be 12. And then you could work out the next term as well. But we just need really the first 2 terms here. So the next one would just be 9. But we have a and we have r, so we can simply find the sum to infinity. So we do a over 1 minus r, so we 16 over 1 minus 3/4, and this will give us 64. Now the next question says find the other possible value of x, and to do that, what we're going to do is consider the fact that we have a common ratio here. So we know that u2 divided by u1 must be the same as u3 divided by u2. So we know that x plus 4, the second term, divided by the first term, which is 2x, has to equal 2x minus 7 over x plus 4, the third term divided by the second term. We're going to rearrange this by timesing both sides by x plus 4, and we're going to also times both sides by 2x. And what happens there is we get x plus 4 times x plus 4, and we get 2x minus 7 times 2x. Don't know why I put the bracket there. So expanding this out, we get the following. And with a bit of rearranging, we get 3x squared minus 22x minus 16. You might be thinking, oh, I don't want to factorize that. I'm going to go straight to my calculator. However, we know already one of our solutions is x equals 8. So I know that x minus 8 is a factor. Okay, think about the factor theorem. If 8 is a factor, sorry, if 8 is a solution, well, if you put in 8, there we go, got there eventually. If you put in 8, you're going to get 0. So x minus 8 therefore must be a factor. So you know that's one of your factors, so you can quite simply deduce that the other one must be 3x plus 2. So we get 2 solutions there, x equals minus 2/3 and x equals 8. But we already had the 8 from earlier. So our other solution just must be x equals minus 2/3. And you could put that back in to your sequence and check that it does work out as it should. Let me know if you've got any questions. Just to tell you what you're doing next, it is going to be doing some more questions, exam style questions that we want you to attach, but please do still have a go at exercise 3E from the textbook. Don't just limit yourself to just doing exam questions. Try and treat this as, make sure that you kind of do a full kind of hour and 10 minutes work that you'd normally do in a lesson. And also then obviously the additional work that you do outside of the lessons as well. A final reminder, if you didn't get at the start, binomial normal distribution test is on Friday, the 22nd of May. There'll be a form coming around shortly if it hasn't come around already, for you just to confirm that you understand and that you can do that test. It'll be 11 o'clock on the Friday. Take an hour and then half an hour to submit your answers. and basically let us know if anyone will have let us know if you do have a problem with that. We'll be back here on Thursday for the next lesson.